3 years ago, COVID-19 happened, and it had a huge impact on our daily lives. We had national governments that imposed policy measures, all targeted at containing the spread of the virus, but still they cut into our personal freedoms. And so these policy measures were, and I would say rightfully so, heavily discussed on social media. We also observed something else in that time, which is the spread of misinformation, that is the voluntary spread of false information with regard to COVID, and conspiracy theories. The picture I'm showing you here is from a protest gathering in Vancouver 2020. So people came out to protest, and you can see one instance, one example of such a conspiracy theory. This particular one made Bill Gates somehow responsible for COVID. But the thing is, the surprising thing is, people, or the belief was so strong that people actually go out on the street and protest for it, right? That's something you have to imagine. Another instance was the 5G conspiracy theory, which also happened during the time of COVID. So people made telecommunication technology, I would say, somehow responsible, linked it to COVID. And what happened? Well, cell towers in the UK were attacked and set aflame. The point I'm trying to make is the social, like conspiracy theories and misinformation, they spread in the virtual social network world, right? But they have a direct impact into our, I say, real geographic world, attacking cell towers, protest gatherings. And that's what I wanted to study, and this is what I want to talk to you about. So what I did was I analyzed the COVID-19 protest movement, misinformation, conspiracy theory targeted against anti-vaccination mainly, for the use case of Austria. And today I would like to show you what I did and how I did it. So I will first talk, of course, about the data, the Twitter-based analysis, and the approach that I use, going through network analysis, a bit of semantic analysis, and the main focus always spatial analysis. And of course, we will discuss the results here. What I would hope that you can take away from this talk is, the first point is how to use social media for researching a movement. This can be, the things that I'm doing can be applied to other settings as well. And with that, I hope that you also understand why the availability of social media data is so important and so crucial for research. And of course, this research wouldn't have been possible if the open source libraries out there wouldn't be developed by the people and wouldn't be taken care of. So that's also another important point. So with that, let's get into it. Let's talk first about the data, and I took an example here I think you can all relate to. This is a user profile of PyCon Italia on Twitter, and I just want to look at it and just make it clear what kind of information we have in Twitter, because the kind of information is kind of manifold. First of all, we have the user information. A user can be a person, but it also can be an entity, an organization, in this case PyCon Italia. They provide a short description. Importantly, they describe a location which I would say they define as their, I call it sphere of influence. That's how I describe it, so where they interact. And we have information about followers. And if we look into a specific post, we see content, textual content mainly, a tweet, also known as, images, videos, data, a date, and mostly metadata around that. So that's the information that we have available, really rich. And what I want to focus on, and what I try to focus on, I don't know why this happens in LibreOffice, I'm sorry for that, is the geospatial dimension, the network dimension, and semantic dimension. What do I mean by that? Geospatial meaning location of users. I want to analyze how location comes into play, let's say, which kind of conclusions can I draw through looking into location. By network, I refer to user-follower relationships. You will see that in a second. And semantic means essentially the tweet text. And now let's look into each of these dimensions individually. When I talk about network, I mean the following. Look into these two statements. We have the first one. User 1 is followed by users 3 and 4. And the second one, user 2, is followed by users 5, 1, and 3. So this information can be modeled or represented in a graph structure. So we can say users are entities, nodes, and their relationship can be modeled as an edge in a graph. And if we take that, we retrieve two separate graphs and we put them together, we end up with the graph structure on the right side. Meaning in our Twitter case, the node are Twitter users, people who interact on Twitter. The directed edge means user A is followed by, ergo the user gets their feed. An information flow can happen. That's clear. Why do we do that? Well, networks have proven to, let's say, provide an interesting form of conclusions. If you analyze network structures, and I will show you that later, you can draw interesting insights from the structure, in this case, about the social network. Now, I told you that I want to study the Austrian COVID-19 protest movement, and how do I do that? Well, there's a thing in Twitter, people follow people, especially in the extreme cases. If we talk about far right, if we talk about conspiracy, people tend to follow other people due to like-mindedness. This is research in social sciences. So what we did, and this is mainly work that my colleagues in the communication science department did, they essentially, at the time when COVID was, or the conspiracy movement, the protest was high, they browsed through journals, they browsed through newspaper articles, Twitter, Telegram, all kinds of channels, to identify people in Austria that were active in a protest. Active means they were spreading misinformation, maybe even conspiracy theories, maybe even mobilizing to go to a protest. This were political actors, doctors, like all over the spectrum. What they did, they compiled a list of 100 people, and we used that list to crawl the network. So those were the start users. Those were the people that they identified. We retrieved their followers and even their followers. And this is how we build up the network, and this is how we ensure that the network that we're studying is actually related to COVID-19 and the protest. And how we do that is quite simple. Once you have identified the people on Twitter, the users there, you can retrieve their IDs, just some pseudocode that I put there, and you can just essentially iterate through the user IDs. And when Twitter's API was still accessible for research, you could actually retrieve the followers, and I would say all of them. It took a bit of time, but you could retrieve a huge list of network data. Not possible anymore, or not for free. What we then do is, of course, store the network data. In this case, as the data was really easy to handle, so it was not as large, and I didn't need any consistency, redundancy, atomicity guarantees that a database would deliver. It's really straightforward to just put it into a CSV file in the form of user ID, follow ID, iterate through it, and use networkx or networks, I don't know how it's pronounced, to build a graph down there. And once you have the graph structure with networkx, you can essentially, it gives you the Python representation to perform all kinds of, let's say, network-related algorithms on it, community, centrality, etc. I'll show that to you later as well. So that's the network dimension. Keep in mind we have users and followers on Twitter, a directed edge here between them. And with that, let's talk about the spatial dimension, how I call it, or how location comes into play. In the case of Twitter, it's a bit trickier, the one that I use. So look into this example. This is PyCon.de. They did not provide, or they provided Germany as a location in their bio. And I told you that we assumed that the location that the people provided is their sphere of influence. Well, this might be true for PyCon.de. It's Germany. It's probably active all around Germany, but it's really not like fine granular enough. For the case of PyCon Italy, it's a bit better because that's city-level resolution. They provide Firenze, so we assume they're just active on Firenze. And if you think about not organizations, but people, this might even be more true, because if I say I'm in Salzburg, Austria, this probably also means I regularly interact there, probably. So that's the assumption that we made, which is, of course, ambiguous and tricky. Once you have that, that's just a textual description of your location, right? It's just a string. And what we need is a geographic representation of that string, meaning we want to know the coordinates of Firenze or Germany, or whatever that is. And this process is called geocoding. Ever heard of that? Good. Geocoding essentially is what all of us do when we open Google Maps and type in, please route me to this hotel here. It takes a reference, Grand Hotel Mediterraneo, and translates it to a coordinate, matches it somewhere, and routes you there. We can also use, because Google Maps is, after a certain point, expensive, you can use OpenStreetMap, Nominaten. Same service, you just provide a string, Firenze, and what it gives you is the geographic, let's say, the way we refer to that is the bounding box, right? This is the area that's surrounded, or is Firenze, let's say. This is a description of that, and the center of that. And the center is a coordinate, this is the coordinate we use. Center is most likely the city center in some definition, or it's the center of this area, the centroid here. And this is the coordinate we use for that. And that's something you can automate quite nicely using the libraries like GeoPy. GeoPy is neat because then you don't need to type that in manually. It implements already an interface for Nominatim, so you just import it, say import it in Nominatim geocoder, provide a list of locations that you want to geocode, call your geocoder, send the API call, and then of course you get the location back, the address and the coordinate, and that's how we did that. And the nice thing is it is free, it's out there, it's open source. Once you have the location reference, once you know where the people are, you essentially have a mapping of user ID and coordinate. And once you have the coordinate for user ID, you still have a data frame, for example, for users, but you can also perform all kinds of spatial queries on top. What do I mean? I mean some things like give me all points around, like in a certain radius of point X, or give me all points that fall into a certain shape. And this is easily done with geopandas, which is, I hope I don't say anything wrong, but I think it's like more or less a wrapper, an extension of pandas, which extends the pandas data frame, the data type with essentially one column, the geometry column, and this is where you can operate all kind of geographic operations on it, be it projection from one coordinate system to another, or spatial queries. This is geopandas. It's really neat for, I would say, small to mid-sized data sets. If it gets really large, you need to think about using a proper GIS database. For example, there's Postgres and the Postgres extension, which then performs way faster, of course. It's just an excerpt of the data that I had. So remember, I was talking about users in a network. So each ID here represents a user node. And I have the location that they provided in their bio, and I geocoded that so I get a geographic reference, a coordinate. And if I take this information and plot that, I end up with something like this here. So what you see is the plot of the complete network that we retrieved when I initially crawled with the data set. And you'll already see a couple of problems. Let me explain first. Of course, the orange dots are our users, and the white lines represent edges, meaning connection between users. And what I did was plotting the users on to the location that they provided. The thicker a line is, it means more connections follow along this route. So you have lots of connections between Europe and US and so on and so forth. You also see it's a worldwide network. You know, it's because I crawled start users, layer 1, and then another layer of followers, which I wouldn't do again, because if you know current research, the degree of separation in social networks is something around 4. Means starting from me, if I do 4 hops in a social network, I end up with me 4 to 5, something like that, I think. And which means 3 layers of followers is already too much. But at the time when I wanted to correct the research that I did, Twitter's API was closed, so bit of troublesome. So I had to, like, with the knowledge that this is a limitation in the analysis, we continued, and we, I think, did our best to counteract that. So that was network and spatial. So we know we have users, we have followers, we have the edge between them, and we have each user has a geographic reference. There's somewhere in the map. Now let's talk about the semantic dimension. What also used to be possible with Twitter's API up to a certain point is crawling tweets per geography. Let me explain. It was possible to say to Twitter's API, hey, please give me all tweets around a certain location. So you sent in a GPS coordinate and said, give me a sample of the tweets. And the research group I'm in used that for the last, I think, 5 to 10 years to build up a huge database of georeferenced tweets around the world for academic research purposes only. And what we ended up for in our case, this is how powerful this actually is. So I retrieved 6 million tweets for my analysis from this database, although I was even late to the party. So I started the analysis later than COVID was a thing, 2020 to 2022. Something between 6,000 to 10,000 tweets per day in the DACH region only, limited to the users in my network. And that's a huge amount of data. So we were able to crawl, I think, something like around 1 million tweets per day, georeferenced tweets. And this was all, like, this enabled a huge amount of research. And once you have that, if you want to deal with tweet text is a bit different from, let's say, larger documents, larger text document. Tweets are short, they contain hashtags, they contain emojis, they contain mentions, and so on. So you need to deal with that. You need to remove rare words, for example. You need to also remove not safe for work words if you don't want to, or if you don't want to include them in your analysis, and so on. And once you have that, you have essentially a data set of network with spatial reference, and you know for each user in the network what they are talking about in terms of tweets, roughly. With that knowledge, let's walk through the analysis, and let's start with the network. And for that, I think I should briefly familiarize you conceptually with the concept of communities. If I tell you the gray bubbles are communities, you'll intuitively know what I mean, right? It is something, this is the structure in the network. If we translate it into the definition, it means each of the nodes, for example, in the left bubble, gray bubble, have more connections within themselves than to the other gray bubbles. That's a community. Why are communities important? Well, if you think about information flow in a network and nodes as users who communicate, then the left bubble will probably form an information bubble or something like an information trap or social bubbles, as we say that, right? You're essentially your social bubble that you are on Twitter. That's communities, and we can detect them also with networkx with a couple of the different types of algorithms implemented, Louvain, and for modularity optimized, there are also hierarchical ones, whatever you need. We did that for the network I just showed you, and keep in mind that this is just the community detection algorithm doesn't know anything about geography. It doesn't take the geographic reference into the algorithm itself. We ran the community detection algorithm, and what we ended up with is this. So each color on this map represents one community. You can see the orange one, for example. It covers almost entirely Austria. It is clearly separated from Switzerland and Germany. And also, if you look closely, of course, Netherlands and Denmark are clearly visible, but even there, this region here, this is the region around Barcelona. It's a Catalan region, so it's its own community. It's its own information community. So what does it mean? We just built a network of protest actors, we detected the communities, and we just decided to plot them on the map, and what we found is they actually correspond to geographic or align with national boundaries. This means the network of protest actors actually communicates more closely within national boundaries than externally. And that's important because we know that the protest, at least in Austria, was targeted against nation states, right? Or let me put it differently, what you could have also expected is that because Germany, Switzerland, and Austria speak the same language, German, it could have also been one large community here, but that's not what we find. So that's one way how combining network analysis with the spatial dimension in the data is, can you deliver more insight, or let's say deeper insight than just plain network analysis, right? Just one example I wanted to show you. Similarly with centralities, centralities are a rank of measuring importance of nodes in a network. There are different kinds of them. I'm going to make one brief example. Think about the one node in the left bubble which connects to the other ones. So imagine this one is a Twitter user, and another one, let's say the one up there, decides to tweet about a party or drinks afterwards after this event. There's a drink going on. Imagine this node does decide not to retweet. What happens? The other community stays uninformed, which means this node has a high control over the information flow in the network. That's called betweenness centrality. So there are different ways of measuring importance in a network, and centralities is like kind of the term for that. Keep that in mind. I'm going to refer to that back in a second. Just need to talk about a concept that's called spatial clustering. So again, here, when I show you spatial clustering, look on your left, please. That's clearly structured. It's clear separation, red, white. And not sure if you can see that, but there is a value below. That's Moran's I. It's almost 1. It's a measure of global spatial clustering. So if it's 1, it's completely clustered, and this one is almost completely clustered, segregated. On the right-hand side, the value is way lower, and you can also see what it means. It's like the values are more spatially random. There is not really a clear pattern, at least at a global scale. And spatial clustering is a way to assess that. It's not entirely random. If you look closely, there are like a white cluster and a red cluster. And that's something that you want to capture with spatial clustering. Now, thinking about, again, the centralities, importance of nodes and spatial clustering, what we can do now is this one here. So this is, again, the network of protest actors that I showed. We calculated the centralities of the nodes. And what we find is that people with a high importance of the network, who are also surrounded by other peoples with high importance, tend to be only in the DACH region. How do we interpret that? Well, while we understand that, you know, the targets of the protest movement were mainly nation states, important people seem to be still in the DACH region. So there's no, we couldn't really say that there was an influence from external, which was suggested and other studies also found, with, especially with QAnon and the US. We were not able to detect that in that scale. I have 5 more minutes left, but I'm still briefly going to talk about the semantic part because I think it's really interesting. There are ways to deal with textual data to essentially grasp what we identify as a main topic or a main theme in the data. I'm not going to go briefly into the details. And I would like to show you 2 examples of that. So let's first look into one user community in the DACH region that I found. So what you will see here is one community that's clearly clustered around one person. Right-hand side is a network, left-hand side is the nodes on a map. There's one person, one user in Switzerland, which has a high out degree. That's why he's colored in red or larger, which means a high amount of followers. So meaning this community is structured clearly around one opinion leader, okay? There's one person, or maybe 2, there's also one in Vienna, who are highly influential in terms of out degree. There's another one which is structured differently, like not that one person with a high out degree, but several ones with like medium size of amount of followers. Also looks differently. Just 2 instances. What I did now is I used those 2 communities, and what I wanted to find is, let's say, the community that's talking about the conspiracy, the misinformation and so on. Didn't find it, but still something else. If we look into this first one, which is highly influenced by this one person in Switzerland, if we look into the outputs of the topic modeling, that's mostly against public broadcasting. Do you know the concept of public broadcasting's fees? So in Germany, you have to pay a certain amount of money to the public broadcasting services, which are independent of the state, and it essentially ensures independence of journalism, from economy, and so on and so on. And those people in this community, they don't like it, which is interesting. It's not like a strong indication for any kind of protest movement, but it still shows there's a certain affinity, right? I'm gonna keep it short because I'm running out of time, I think. Just one comment, that's a Turkish-speaking community. All of these people in this community were mainly speaking Turkish. So you see the kinds of like information and the richness that we can in this data, which allows us to draw like in so many directions, so many conclusions. And it was just one excerpt that I showed you. And what I would like you to take away again is you can do you could do the same thing up to a certain point with Twitter's API. Now it's closed, but there are other social media platforms, smaller ones, where you can attempt similar things. Social media is important for research. It is really a driver. It enables so much. The group I'm working in is also looking into disaster management and epidemiology through social media. Think about people tweeting, I am sick, or think about people tweeting, I am in a hurricane right now. This all can be covered through social media data research. This is something that I really want to kind of pay attention on because the situation is currently a bit bad. That's it from my side. If you have research ideas, if you want to discuss, please contact me. I would be more than happy to collaborate. Actually, on PyCon Berlin, someone approached me afterwards and had exchanged some ideas for a research project, which I found super cool. Go ahead. I'm open for your questions now.
Thank you for the talk. And we have some questions. The first, how many people of the ones you crowd had a useless location? For example, a website link or a phrase like the word or earth?
A very good point. I think I didn't mention it, right? Fake locations is a huge thing. So first thing, let me show if I have it in my appendix slides. Yes, I do. I think I lost 50% because they didn't provide a location at all, and a certain amount of percent because the location reference wasn't geocodable, which means nominatim couldn't make sense out of the textual description. This then refers most likely to things like, you know, I'm living in the world or in the universe, something like that. It's a problem. This is something I needed to filter in the data, yeah.
Remap with communities plotted. If you loosened the density needed for a community, would maybe Switzerland, Germany, and Austria form a big community?
The density, sorry? If you loosen the density
needed for a community.
I didn't try, I think, if I remember correctly. So I think the modularity scores of these communities were quite high. So I trusted that these results were, I say, reliable. The other thing that I would like to think here is why these results, I think, are strong is, so Austrian communities did spread into German communities, but not vice versa. And that's interesting because Germany is way larger than Austria, right? Austria has the size, population-wise, and I think area-wise not, but population size as Bavaria. So the influence could have been way stronger, but it's a good point. I didn't try it out. Yeah.
Do you have any advice for geocoding a large number of locations in an efficient way?
Yes, you can. You can, of course, set up several of these agents. That's not a problem. I think it's just, as a shared resource, it's important to stay fair, I would say. Just don't be greedy. It's okay. Like, lots of people do it. The service is open for free for all of us. You can set up 100 agents if you want. Just make sure they're using a different IP address. I don't know. But it's not fair.
In the semantic analysis, anything interesting with quoted tweets? Especially tweets from one community quoted into another community?
With quote, I guess it's meant mentioning or reply tweets, or what does it mean?
One moment.
Sorry.
So on Twitter, you can take a tweet, and if you link it, it will be included in the...
As a reply, right?
Not quite, well, not replying to the tweet in the comments. It's it basically appears as if it's a picture inside the tweet.
I didn't look into that. So what I try to do is mention networks, which is a bit different. So if someone mentions someone on Twitter, but this I didn't look into, can't answer. Yeah.
Okay. Do you have a question?
Yes. Modularity analysis has the granularity problem, right? When you're doing modularity as a community detection algorithm, you have the problem of granularity and the modularity scores. Yeah. How did you, like, why did you choose that as your community detection algorithm?
It's a really good question.
Because, like, you have small states or, like, smaller states that could get, like, included into bigger ones, and you have some approaches to, like, go around the granularity problem, but they are not really good. And like better methods like vector clustering, they are not really scalable to
Yeah. It's a very good point. So what I also tried out is Leiden algorithm. I don't know if you know that. It just didn't. So Leiden also optimized by modularity, but it didn't return the same height in modularity scores again. I tried out several of them. Louvain turned out, which I used to be the one that was most scalable and most usable. And of course, there are several ways which you can do, which also offers room for different interpretation. I didn't look too deep into that, to be honest.
Did you get like huge help from like influencers or people that like were really connected to others and they don't really help?
Say again, sorry?
You got like really big hubs in social networks that are like influencers or people that are have like a huge amount of connections, like they are towards them, but they don't really go out. I usually try to cut them out. Or
Yeah, absolutely. So.
I think for this kind of communities, it's better.
Please keep it concise.
Yeah. So I think the comment is completely valid. So we have a problem with the structure of the network. If you think about the network that I showed you, the density in the network overall is kind of low, which is due to the crawling strategy. If you think about the way that we crawl, we start with start users, followers, and followers, which means we end with lots of leaf nodes where we never retrieve the followers of that. And it's a problem. It's a limitation of the study, certainly. I still find that I trust the results that I did because we checked that a lot, like for a sense of validity, in the sense of checking the communities, what they talk about. We checked for the users that we identified as important. So the results seemed in a manual probe absolutely valid. But of course, they need and can be improved with terms of the algorithms applied and with terms of crawling strategy, as I said, definitely. Sure.
All right, we finished the time. Thank you very much again for the talk.